Hello, everyone. Welcome, and thank you for joining us for today's webinar, MES 2023 Predictions, How to Navigate the Economic Triple Squeeze. My name is Megan, and I'm the moderator today. Today, our subject matter experts will be discussing the key pillars of the triple squeeze on performance and its impact on manufacturers, 2023 predictions, fundamental changes in manufacturing, and those shifts in manufacturing are here to stay. And then how you can navigate the triple squeeze, our recommendations for this year and beyond. And now I'm excited to introduce our speakers. Mark Field leads our portfolio marketing team at Tulip with 20 years of enterprise software experience, focusing on product management and leadership at companies like PTC and QuickBase. Eric Marandet leads product and ecosystem at Tulip with over 16 years experience building and leading teams in customer success, operations, and product development. Okay, take it away, team.
All right. Well, thank you, Megan. I will get us kicked off. And first and foremost, thank you to the audience and everybody who has decided to take some time out of their day today to learn a little bit about the triple squeeze. What we hope to accomplish today is help folks connect the macroeconomic pressures that we see in the environment to how you as CIOs and operational leaders in manufacturing should be thinking about their digitization strategies. So at the top level, the triple squeeze is putting unprecedented pressure on manufacturers. And this increasingly complex environment, which in some ways began with the pandemic, it's here to stay. So that complexity is here to stay. And this means a new reality for manufacturers. The environment in which we're operating in is no longer just complicated, it's complex too. And those are two different things. And this added complexity changes things. So we'll get to the difference between complicated and complex and what it means for manufacturing. But let's start by defining the triple squeeze. So as you can see, the triple squeeze has three main pillars, none of which I'm sure is a surprise to you. One is inflation, and probably better said, the volatility in prices, because some prices are most prices are going up, but some prices are going down, and there's a lot of volatility in today's economic environment. We see that in day to day, and we see that in our business operations. Supply chain disruptions, frankly, they haven't stopped. Most executives are expecting them to continue this year and beyond, and the labor shortage is still a big issue facing particularly manufacturers, because it's really, really hard for us to bring new young workers into the workforce, particularly as some of the more mature workers are retiring. So how does this impact your digitization strategy? That's really the question. So what we see is the complexity in the operational environment caused by the triple squeeze means that efficiency is no longer the top focus. And it should no longer be the top focus of CIOs and operational leaders. Efficiency is important, but it's no longer sufficient. Manufacturers need to develop resiliency in their operations. And this resiliency is what helps them adapt to disruption across the supply chain, the economy, and the world. So the triple squeeze is going to challenge mainstream thinking about digitization strategies for manufacturing companies. It means thinking about how to get more out of your existing information systems, more out of your data, break down the silos to improve the reporting of performance, the reporting on costs, and get more insights into work patterns. It means thinking about how to shift your expenses from capital expenditures to more controllable operational expenditures. And it also means investing in the people who run the front lines of your operations, to engage them, make them more productive, bring them into the problem solving, bring them into the world of helping you solve problems and capture their insights and know-how for future generations of workers. So the triple squeeze is going to have a massive impact on the digitization strategies of manufacturing. It really means that these strategies need to result in systems that are more adaptable than ever, and it's increasing the importance of composability, extensibility, and the democratization of the systems that are used on the front lines of operations. So, Eric, why don't you walk us through this new reality of increasing complexity that's reflected by the triple squeeze?
Yeah, thanks, Mark. So, I mean, when we think about manufacturing operations, we've got customers all over the world who are navigating this macro environment. We're navigating this macro environment as well. And there's a couple of things that we see that are like marked shifts from sort of past ways of thinking. And I think, like, you know, if we were to summarize this, you know, conceptually, the observation that we see back here at Tulip is that there is this shift, as Mark is talking about, from complicated to complex. And I want to just take a moment and double click what, like, the significance of this shift, and then what are we actually saying? You know, complicated, complex, on the surface may appear to be synonymous, but they describe two different types of systems with different characteristics. And the way that you approach problem solving in the context of these types of systems are also very different. And so let's start with complicated. So a complicated system is one that has many moving parts and lots of different things that need to be planned for. But fundamentally, you're operating with a set of knowns, and you're assuming that the system can be understood and solved for. You know, so when I think of a complicated system, the mental model that I have is one of a finely constructed Swiss watch. You know, it's very intricate, lots of moving pieces. All of them have to work together in just the right way in order for that watch to perform its function. But it can be understood and it can be engineered in such a way that it will always work as planned, as expected, and it'll do the job that's required of it. Now, if we transition from a complicated system into the world of complexity, we're dealing with a type of system that is, like, fundamentally different from that of the complicated system. Here we're dealing with things like complex. No one person knows what's happening across the whole of this system at any given point in time. There are complex systems have all sorts of interdependencies that exist within them. They have all sorts of unknowns, some of which you know you don't know, and many of them you don't know that you don't know them. So the way you approach problem solving in these environments is fundamentally different. And, you know, a classic example of you know, if you ever want to nerd out on complex systems theory, you know, please shoot me an email. We can chat. But, like, specifically when we're describing manufacturing operations, these are a specific subset of complex systems, complex adaptive systems. A complex adaptive system is characterized by, it's a complex system first, as described, and then second, this complex system is populated with agents that are constantly learning and changing their behavior in response to changing conditions around them. These agents, in the context of, you know, global manufacturing operations, they're the people. There are associates, there are engineers, there are supervisors, there are leaders of these operations. And as things change within their environment and outside of their environment, like, you know, what we're talking about with the triple squeeze here, the sets of decisions you make also change in ways that are not always predictable. A classic example of a complex adaptive system that we all deal with every single day is traffic. You know, this is a Google map from how I get to my house to the office where I'm taking this webinar from. And I live about 1.5 miles away from the office. And as you can see, on any given day, that might take me 30 minutes. It might take me 10 minutes. I might go many different ways. And what's going to determine the best course of action for me is the state of the system at that point in time. You know, somebody's driving down the road and they see a deer and they look, and then they crash into the car in front of them, and my main thoroughfare, the way I would normally get there, is no longer available, and I need to go a different way. The other thing that's interesting here, and I think that there's you know, there's some themes that we're going to be continuing to build on that I want to double click, is how good I am or how quickly I'm able to get to the office in the morning, how well I'm able to navigate traffic, actually has very little to do with how good of a driver I am. What gives me the tools I need to be able to do this job very effectively is the level of awareness I have about real-time state of the system that I'm operating within as it relates to my decision-making at every little street and every little turn along the way. So in a world of complex adaptive systems, and I would argue that this is the world that manufacturing operations have been thrust into over these last few years. Pandemic certainly didn't help, and we're seeing these effects go long beyond that. Those who have real-time visibility into the state of their system and who are able to actually act on that information are those who are best suited to be able to navigate this environment.
So, Eric, as I digest what you were talking about, you're saying that there are some real implications of this that pertain to the manufacturing industry. So what I took away from that, Eric, was, hey, look, the efficiency is great at managing the knowns, but in complex environments, you also have to manage the unknowns. So in a lot of those cases where you have to deal with unknowns, efficient systems, while important, could slow you down. And that's why resiliency and adaptability are now priorities for how CIOs and operational leaders are thinking about their digitization strategies. And that kind of reminds me of Piaggio Fast Forward, who's a manufacturer of robotics, where their main message is, hey, look, having that quick reaction time is really important in today's production environment. So these folks were creating a brand new operation to build robots, and they were doing this in a new location with a brand new workforce. So they were faced with a bunch of what you described, Eric, as the unknowns, especially when it came to workers and when it came to the operations of how to build these new robots. So they deployed a system across their production operations that allowed them to adjust and adapt both their systems and their people as they encountered problems along the journey to building that brand new operation. And this is what provided them adaptability and agility in a regulated environment. So if resilience and agility are now priorities for manufacturing, what does that mean for digitization strategies in 2023?
Yeah. And that's the question that we get asked, right? So, if this is the reality that's here to stay, what does that mean for me specifically? And what I'll tell you, the ways that our customers are navigating this macro environment and navigating their own internal dynamics, their own internal operations, and the demands that places on a software vendor. At the end of the day, we're here to serve our customers, and we're here to make the people who are responsible for operating these types of environments successful and give them the tools they need. And what I will say, one thing that I've seen over the last couple of years, really most pronounced in the last 12 months as Triple Squeeze is here and we're navigating this environment, is that fundamentally the way that our customers, the way that manufacturers more broadly are buying and implementing software is fundamentally different than in previous eras. And I would go a step further, and I would say that there is no going back. This, for me, again, we're here to serve our customers. This isn't an optional thing, and this isn't a nice to have. These are the demands that we're seeing placed on the Tulip product, and we're here to support them as they navigate this environment. And it has profound implications, not just for how we build the product and how we build the software, but also for how you implement these tools to get the perspective you need, to get the value that you need to be able to navigate this type of an environment. And again, what I would say is, the focus has shifted from being optimally efficient, making sure that you've got not any slack in the system, the optimal output per unit effort, again, given a static and known complicated environment, is going away, And there is an increasing premium on the ability to weather shocks to the system, the ability to change, to be adaptable. When things change, you've got to be able to respond in kind, and you don't always know what's going to change before it happens. In fact, increasingly, that seems to be the case.
Yeah. So let me just break that down. When we say that how manufacturers will buy, deploy, and implement software has changed forever, that really breaks down into three things. One, the cloud is now mainstream and manufacturing is a deployment platform. Owning software is dead. And we think the traditional professional services model is dying. So let me go into each of these a little bit more. So first, cloud-based deployments now are accepted by manufacturers and lots of other industries as a deployment platform for running mission-critical processes. And this is great because this eliminates a whole bunch of non-value-added capital costs associated with on-premise or colo types of deployments, because those hardware and software costs will now be assumed by the cloud provider. So that's great. And it also greatly simplifies deployment and maintenance of these systems because keeping the infrastructure safe, secure, and performing well is also assumed by the vendor. So these are pretty crucial considerations when it comes to addressing these triple threat pressures related to costs, related to resiliency, and finding skilled workers, because no longer do you need to worry about finding these skilled IT workers to manage sort of low-level infrastructure things. So that's one. Second is subscribing to software as a service is now the de facto approach for buying enterprise software. Nobody wants to capitalize a purchase, a software purchase, and then be stuck with that on a 3 to 5 year depreciation cycle. Software is just changing way too fast. SaaS licensing allows manufacturers to buy software a little bit at a time, test the waters, start small, grow as value is realized. So buy what you need when you need it, grow as you see value, and scale back when that value is diminished. And thirdly, where we think we'll see the biggest change in 2023 is around how manufacturers think of traditional professional services. In a complex world where change is a constant, the long and expensive system implementation projects associated with manufacturing software that leave you beholden to the vendor or a systems integrator for changes and improvements, it's a showstopper. Short, iterative, value-based service engagements designed to empower you as a manufacturer will begin to take hold. That's a big change we see coming. So
and if I just
look at why we believe 2023 is the year of these fundamental shifts in manufacturing. So Eric, you want to kind of walk us through this?
Yeah, and I just want to add to your last point before we move on to this next topic here. You know, we've always had a really strong professional services team at Tulip. We've got global partners, and they're great. Our customers often we'll work with them. Our customers will often use our professional services team. And so what's interesting here, and I think to Mark's point, when we say the traditional professional services model is dying, we don't think of this as we're going to come in and we're going to implement the perfect solution for you and then walk away. Our team here is called the adoption management team. So the focus of those professional services engagements is helping customers understand how they can use these tools to better navigate this environment. And I think that there's still a role for professional services to play, but the point is the reason that they're there and the objective and what success looks like is materially different in this type of an environment. If we look at it and we say, hey, we implemented a solution, it's static, it's going to solve all your problems, and then we leave, but our customers and our users don't have the ability to actually understand and take ownership and iterate and continue to build and deploy, then we don't view that as a successful engagement. So I think that it's just an interesting transition that's happening here that's worth kind of underscoring. Well, with that though, let's shift gears and go on to this next topic here. So traditionally, what let's first compare the before and the after. We say, I made the claim earlier that the way that customers that they're purchasing and implementing software is fundamentally different. It's fundamentally changed, and there's no going back. So I just wanted to double click. What are we actually talking about when I say this? And if you think about how software in the past has been implemented, it is it's a fairly long process. You start by saying, okay, let's analyze our process. Let's understand the problems we want to solve for. Let's build an RFP. We're going to, send out proposals. We're going to get a bunch of responses to these proposals. We're going to go with the lowest bidder because we're trying to save money. And then we're going to go ahead and select the vendor, and we're going to make our purchase. Okay. And maybe this takes us 6 months. 6 months may be a little optimistic, but let's say that whole thing happens. You've mapped your process. You know exactly what you want to do. You know exactly what the system is going to do. You select the vendor. They're through procurement, and that all happens in 6 months. And then you go through your implementation phase where, now we're architecting, what does this backend system look like? We're going to do some custom development to modify it, because no out-of-the-box solution the fact of the matter is every shop floor is unique, and the requirements of every operation is a little bit different. And so there's always a trade-off that needs to be made. Do I change the system to accommodate my operation, or do I change my operation to accommodate the constraints of the system? So you make those decisions, you roll it out, you implement it, you go through QA, you probably validate it. You may start with a limited rollout on one line, and then once everything's looking good, everybody crosses their fingers and you do the big bang, you turn it on, and you're live across all the sites. And those are usually pretty stressful. Those are usually pretty stressful events for those who are involved. But let's say that takes 12 months or 18 months. So the thing that we're saying is changing, and the transition that we're seeing is, it is no longer acceptable to wait 12 months for that value rollout. If you do a limited this whole process that I just described, value doesn't get created until the system goes live. All of the planning, all of the architecting, all of the customization, all of this stuff, it doesn't actually solve any problems until you roll it out. And in the world of a complex adaptive system, where these environments are increasingly dynamic and you're having to respond to fast changing conditions both within and externally, you have labor turnover, you have part A sells, part B doesn't, or component A sells, component B doesn't. So you need to ramp up part A, and you need to limited rollout of part B. My point is, these environments are always changing, and if you have to wait 12 to 18 months to be able to get the value for the purchase that you made 12 months prior, and even then, if you're building for the problems that you experienced 12 months ago, it's unlikely that those are still all of the same problems that you're facing. And so the core premise of how this type of technology has been consumed in the past is dying, and we're seeing people move away from it, and I don't think that there's any going back. But by the way, that's only half of the problem. Once you go live, it's not like everybody lives happily ever after, because you go live at a certain point in time and you roll out a system, but as time goes on, drift occurs, and the needs of your operation, as your operation is dynamic and things change and new unknowns come up, and you have to solve for these problems and respond to these macro conditions that that everybody's navigating. As things change, your system isn't designed to change with it, and so this drift occurs. Now, maybe you're in I don't know. Oh, maybe you're in automotive or semiconductor, or you're in an environment where this change is minimal. And so, best case scenario, the value proposition of the system is as good as it was on day one, and it lasts for a few years. That's best case. Maybe you're in a more dynamic environment, and so that drift happens more quickly, and the value actually decreases over time as your operation continues to evolve. And as this happens, so I guess best case, you're left with a static value proposition. Worst case, the drift happens sooner, and you actually see decrease in value over a period of time more quickly. And then as this happens, what do? Well, you look for point solutions for the most part. You say, oh, well, we had this problem. We didn't have it 15 months ago when we initially rolled out this system, or 2 years ago when we implemented the system, 5 years ago when we implemented the system. But now we have to solve this other problem. So let's look for a point solution that addresses that issue. Oh, but there's another one. So let's go find another point solution. And that's how you kind of prop up the operation in this type of environment, with a monolithic static system that solves a finite set of problems that were defined at some time in the past. Now, the other challenge with that is, all these point solutions that you're implementing to prop up the system and keep your operation, all they're doing is introducing additional data silos in your IT stack. And so now, in addition to having a system that is increasingly out of touch with the reality that you're navigating, you've now introduced all these other additional data silos and further fragmented the visibility you have to the whole of your system at any given point in time. So with that, we're going to double click some of these themes in a moment, but I want to just pause for a minute here and take a quick poll. The question we want to ask is, over the last 12 months, a lot's changed. And the question that we have for the audience is, today, as you look at your operation and you look at your budget and you're navigating the uncertainty ahead, are you more or less confident taking on a big system implementation today relative to where you were 12 months ago? And your options are, more confident, I'm feeling better than ever, still confident, not better, but not worse, less confident, or no confidence at all.
So Meg, what are we finding in the results?
Responses are still coming in. Right now, the top selected option is less confident. We have less budget and resources. And then for the rest of them, it's relatively evenly split between not confident, still confident, and some are still, still confident and more confident. But overall, we see around 70% total are either not confident at all or less confident with less budget and resources.
Got it. All right. Well, let's kind of reflect. What we've established so far is that the triple squeeze is bringing complexity to the manufacturing environment. Dealing with complexity is going to challenge how manufacturers are thinking about their digitization strategies. Efficiency is no longer enough. Resiliency and agility are now priorities for dealing with the triple squeeze. Adaptability is a critical requirement for the digital systems that are going to support resilient and agile operations in a complex environment. And the traditional approach for buying and deploying and implementing systems on the manufacturing floor, it's not adaptable, it's not agile, and so the way we buy is going to change forever. So let's now get into what's a new approach given this new reality.
So here's what we're seeing our customers demand from us. And I think that this is not a Tulip thing. I think that this is a result of the macro factors we've been discussing, as well as the nature of manufacturing operations. And what they're saying is like, look, I want to prove value, and I want to lead with ROI. I want to lead with results, and I don't want to wait 12 months to get the impact that I've been promised. So what does that look like practically speaking for us? Typically for us, Tulip is a composable solution. It's a very modular solution. What that means is that you can take on a very specific problem set. You can, launch a pilot, and you can say, look, I'm gonna. There's one or two very specific targeted problems that I want to solve, and there's like known ROI and impact associated with these, and then you can measure it. Did it achieve what you were hoping? Yes or no? And you can do this in the time scale of weeks, not months, certainly not years. So, it's not unrealistic to have a pilot that, launches, goes live, proves result within a couple of weeks. So, this is a very quick process. We work in sprints here. And then you can take the learnings of those. So, you're armed with knowledge that you didn't have when you started that journey at the end of those first a couple of sprints and as you wrap up that initial pilot. And armed with that knowledge, you then can decide, how do I want to take on these next set of problems? Rather than saying, I'm going to solve the whole thing at once, here's the end state, you can say, okay, I'm going to take that learning, I'm going to apply it now to the next line or the next problem or the next use case. The other thing to keep in mind here is that because this is a system that is designed to be adaptable and engaged and owned by the people who actually run these operations and who are responsible for the problems that are being solved here. Once these are implemented, they're not static solutions. So, as the system changes, the scope of these specific, in our world, these take the form of applications. But the scope of these apps can also change. You can modify them, you can iterate on them to make sure that they're evolving with the needs of your operation. And I want to talk a little bit about what's that process look like. So I've done my pilot, I maybe expanded my pilot beyond the initial scope to take on a couple of additional challenges, but still very limited scope in very focused use cases. What typically happens at this point in the process is the operations leaders in IT and our business leaders will come together and we'll do a sort of ease impact analysis where we'll say, okay, now we're armed, we understand how this technology works and the types of problems we can take on with it and how we connect these applications with one another so information is freely shared and made available across the system. And we'll basically say, okay, let's brainstorm a list on a whiteboard of all of the problems that if you solved, life would be a little bit better. And now we'll get 20, 30 of these up on the board and we'll say, okay, how impactful would it be if you were to solve this problem? High impact, low impact. And then we'll say, okay, great. How easy is this problem to solve? Very easy, not very easy at all. And then what we'll do is we'll plot that on a quad chart and we'll say, okay, if it's high impact and pretty easy, this is probably where we want to focus as we think about what are those next types of use cases that we want to take on. If it's high impact, actually fairly complex, this is probably something that we want to keep in mind. Maybe we don't take it on first, but this is typically where there's dependencies on third-party systems or tighter integration with digital infrastructure of various sorts. Usually, this is where you want IT to be in your corner. Usually, there's a role for a center of excellence here. These are big things, but they're worth doing. The ROI is there, but you go into that eyes wide open. And then typically, there's another category of things that are kind of low impact, but pretty easy. This is one of those areas where, if you're a manufacturing engineer and this makes your life better, go nuts, do it. Why not? You don't necessarily need a center of excellence or IT to be involved, but this is typically where you enable citizen developers to sort of, invest time as they see needed and help focus that. And then we also tend to see, we're all engineers and we like to solve problems, but there's always this other category of things that are pretty low impact, pretty hard to do. They also may be intrinsically interesting, problems that would be fun to solve. This is where we say, proceed with caution. Maybe this isn't what you take on right away. Maybe you come back to it, but it's probably not something that you want to start with. So that's kind of our decision-making model when we think about how do you prioritize the sets of use cases that you would take on. Okay, so now you have, you're starting to roll this implementation out. You've got your first use cases identified. They're providing value. You've started iterating on them when and as needed to make sure that they're relevant to the problems that you want to solve. You're adding additional use cases on top of this if in following the framework that I've just articulated. Here's what's interesting. If you think about the value curve that I was sharing with the more traditional systems approach, it's basically no value, then all the value at once, or maybe a little bump with the limited rollout and then all the value at once. What we see here is as you're taking this process on, and each of these sprints, can be a couple of weeks long or a month long. So, and because you've got this iterative approach to problem solving, you're prioritizing those things that are quick and high impact. And so you see this sort of exponential, you very quickly achieve the 80% value proposition at a time scale that is de minimis relative to a traditional system implementation approach. So you forward load those things that are quick and that are high impact, and you see very quickly, you get that return on investment very, very, very quickly in the process. And then you can continue to build on it. And what's interesting as this goes on, remember the nature of the system that we're dealing with here. This is a complex system, a complex adaptive system specifically. Complex systems deal with both the knowns, these are the blue blocks, and the unknowns. So think back when you said, here are my requirements for the system, and here's my RFP, and here's what I'm going to do. You only knew the things you knew when you made those requirements. And then either A, like there were just things that existed that you didn't know, or B, what also happens is like things came up that you didn't anticipate, right? Which is kind of defining characteristics of this environment that we're navigating with the triple squeeze. The interesting thing about this approach is that now you have the ability to iteratively take on both the things you knew you would have to do eventually, as well as the things that come up that you didn't anticipate before. And the value proposition associated with this is actually pretty interesting as well, because you're going to see this quick return on results. You're going to say, hey, we're going to get to that 80% value proposition in a couple of months, 3-4 months, as opposed to 12 months or something like this. And then you're going to have all of these other positive network externalities that are going to kick in, because rather than implementing point solutions to prop up a system that's constantly drifting away from the reality, or the reality is drifting from the system that you implemented on day one, or at some point in time, you now have the tools you need to continuously solve these problems, all within the context of the same platform. And let's think for a second here about like the example that I gave early on was traffic as a sort of a representative complex adaptive system that we all are very familiar with and deal with. Like, how do you solve the traffic problem? Well, like as an individual, if I know real-time state of that system and I know which street to turn on and which street not to turn on, I can make life better for me. I can get to the office faster than the next guy. But there's another point here, which is like, if everybody has Google Maps and everybody knows the real-time state of that system and everybody is able to make decisions that streamline their own workflow, then the system as a whole improves and traffic as a whole becomes more efficient. And we see a very similar thing that takes place when you take this type of approach and you have all of that data that's available in the same common substrate and the same platform. And why has nobody invented Google Maps for manufacturing? Well, traffic is pretty easy. You can pretty much assume that everybody's trying to get from point A to point B in the most expedient manner possible. Manufacturing is much more complex. The nature of the problems that people are trying to solve is fundamentally different and not always knowable up front. And as a result, the end form of that application also is a little bit different depending on what problem you're trying to solve, which is why we've built Tulip at the platform level, in making it easy for people to create their own application that gets the information that they need to make better decision making to the people who need that information. So it's like it's the same conceptually. It's the same as Google Maps. It's just built one layer down in the stack, making it easy for our citizen developers and for our customers to route this information where it needs to go, and thereby optimizing the system as a whole.
Yeah. So Eric, what the real big takeaway that I heard from that is, look, one of the real benefits of this incremental composable approach to creating and deploying solutions is the fact it gives you lots of flexibility to deal with these unknowns that will be coming up in the future and be able to tailor that specifically for your environment. So that helps us deal with change. But there's some stuff that is not changing in 2023 that's really fundamental to everything we do as manufacturers. The problems faced on the front lines of operations, they're not changing. We still need to turn raw materials into finished goods. This is the definition of MES. But what is changing is the environment in which these operations take place. The triple squeeze, inflation, labor shortage, supply chain disruptions, that's what's making the environment more complex than ever. So if we start thinking about, hey, how do we navigate the triple squeeze? we have some recommendations for folks about how to navigate the triple squeeze and create adaptable systems. So in doing this, let's look back at where we were last year and see kind of where the things we were talking about last year stand, right? So start in the upper left-hand corner, workforce transformation. That's as important as ever. Labor shortages are still a key pillar of the triple squeeze. On the right, agility. Agility was a focus. It remains a focus. The ability to move fast, adapt to change, compose these new solutions is a key requirement for building resilient operations. Bottom left, democratization. That is continuing to grow and remain important as we need to find ways to engage frontline workers in solving problems, in augmenting them with digital tools and data so that we can harness their unique and local insights to adapt to the unknowns at a local level. And then new tech will continue to emerge. But as we want to be adaptable, we want to be resilient, we need to have a digitization strategy that is able to take into account old legacy technology, maturing technology, and emerging technology. It has to be open, it has to be extensible. So building on that, we have 3 specific suggestions. And the first, Eric, is this shift to a composable approach.
Yeah, and this is, I mean, really what we've been talking about in that last set of conversations. The idea is rather than trying to solve the whole of the problem up front, rather take an iterative approach and shift to this composable mindset where you say, you know, I'm gonna take the tools, I'm gonna solve a very specific problem, I'm gonna capture the data, the feedback that I get from that problem, I'm gonna make that available to the whole of the system, and I'm gonna use those learnings to prioritize which problems I take on next, and then I'm gonna respond to the feedback that I get from my operators and from the data that's being generated from these applications. I just want to talk a little bit about what does this practically look like. So, you know, here's an example of a fairly typical operation. You know, there's all sorts of different activities that are taking place here. Lots of people responding to lots of different inputs, all organized around work streams. And the types of problems that they might take on, you know, you have things like, you know, it's one thing to speak about this in the abstract, but concretely, what are all these little blocks with arrows on them? You know, the types of problems we see people typically take on are things like production visibility, understanding where a work order is at any given point in time, and if a job is, you know, ahead or behind schedule, and if there's a bottleneck queuing up somewhere, where is that bottleneck and what actions need to be taken as a result? You know, guiding assembly in a complex type of environment where lots of steps need to be followed in sequence to deliver a quality product, or for regulatory purposes. Machine monitoring, understanding if a machine is being used to its fullest potential, and also understanding when a machine goes down, if it's unplanned, what do you do as a result of that, you know? Packing and shipping, process auditing, inventory control. These are all just a few types of examples of the common use cases that people typically take on with this composable, adaptable mindset. And you know, we're not alone in this prediction. You know, Gartner through their research has seen this shift happen, where they're predicting that from 2022 to 2025, you're going to see an increase of composability go from about 2% in 2022 to 25% of total manufacturing operation applications will be built and fielded using this composable approach.
Yeah, so shifting to composability and a composable approach is a central tenet behind that idea of adaptable systems. So yeah. Our second recommendation is to prioritize your most important assets. And it should be no surprise to anybody that your most important assets are your people and your data. So why? Data helps your frontline operators see how their work fits into the broader picture. It engages them in the broader system. It empowers them, and data empowers everybody to solve more problems and make better and faster decisions. So how do you do that though? Data alone often isn't helpful. It's putting that data in context that becomes really powerful and makes it really useful and helps drive bunches of insights. So putting that data in context means understanding where it came from, what line, what piece of equipment, what station, where was it generated, what else was going on at the moment. And it often requires some human insight from the operators involved. So think about that as you think about your digitization strategies. People and data, we didn't separate them out. They go together because people add the context to the data. And then
data in context routed to the appropriate stakeholder is called a feedback loop. And you know what you can do with the feedback loop? You can take action and you can actually make things better. You can see where problems are, not yesterday, not last week, not last month, where problems are right now and where I should focus as a result of this, right? It's all about that visibility and about these feedback loops. So people plus data is a critical point and contextualized.
Yeah. And our final recommendation really kind of harkens back to something, Eric, that you said a little bit earlier this morning, which is demand more from your vendors. The old approach to buying, deploying, and implementing manufacturing solutions, it's not going to work for today's operations that take place in an unpredictable environment full of unknowns. We really need a new approach. So demand more from your vendor in terms of how they think about licensing their software, implementing their software, and maintaining their software. Eric, you know firsthand what you're hearing is demands from folks.
Yeah, absolutely. I mean, I think if somebody, if you have a problem today and somebody says, go ahead and give us a bunch of money, we'll solve it in 12 months, like that company's not going to be in business much longer, guys. This is what our customers are demanding from us, and we're ready for the challenge. If you've got a problem, we want to be able to get that solved. We want to be able to get the visibility, and we want to be able to lead with ROI and lead with impact. And that's the challenge that's where we are, and that's how we're going to be operating with our customers. And you know what, we're not alone. Anyone who's going to be in business and continue to be successful in this environment is going to have to compete in this way. The question gets asked. It's out there. I've heard it many, many times. And is MES still relevant in 2023? This question's been asked. And if you look at the things that we're saying aren't changing, the problem that MES is solving is not going away. And that's that's one of the things that's not changing in 2023. People still need to build things, and that work still needs to be coordinated, and it's not an easy problem to solve. The point that I want to make, though, is that there are different ways of taking that problem set on. You can do this in a composable way. And, if you think back to that, slide look kind of like this, once you solve all of these problems in the same platform and these applications are able to share data freely amongst themselves, what you have is an emergent MES. It addresses these issues. And so, I don't know, my personal opinion is MES as a problem statement is not going anywhere. What's changing is the tools people have to solve that problem and the way in which people are going to be getting visibility into these operations, going to be taking that on with an emphasis more toward adaptability, fast iteration cycles, quick feedback loops, and less toward designing and implementing a static system that you don't have the ability to evolve as the needs that you're facing are continuing to change and evolve, and as you navigate the uncertainty of the triple squeeze.
So wrapping up, I think there's, three key themes that have probably come through loud and clear. First, the focus on efficiency is important. It's just no longer sufficient. We need to start prioritizing resiliency, agility, and adaptability in our digitization strategies as we think about how to adapt to these disruptions happening across the world. So our strategies must result in adaptable systems, and the implementation approach should be something that takes into account both the knowns and the unknowns. So I think those were kind of the three critical themes that stood out to me. Eric, I don't know if any others stood out to you, but those were like the three that stood out to me.
No, I think that I mean, I don't have anything to add. I think that sums it up well. I think what we can do now is we've got a few minutes for questions, so hopefully we can take a couple of questions from the audience. And I just want to say it now. Thanks everyone who took the time to join us to discuss these topics. Appreciate your time and look forward to hearing from you.
Awesome. And one final thing to note before we get into QA, or question and answer, we have a webinar really double tapping on what you should be demanding from your MES. So specific questions you should ask vendors during the RFP process. March 2nd, you'll be receiving some more information on that. And let's get into some of the questions here in the remaining time we have. So first, what are the top pains your customers tend to solve first in the pilot programs?
Yeah, I'll take that one. I think what we often see is people reach out with questions. Oftentimes we'll have people reach out with questions about work instructions, but I would say that's very seldom the actual problem that needs to be solved. Most frequently, the problem that customers are solving first is one of process visibility, just turning the lights on and understanding what's happening across the operation. Where is work? Where is inventory? Where is work order track? Like, where are the work orders? Where are we from a quality perspective? And then, once you measure this, it can very quickly evolve into like a performance management type implementation as well. So providing very specific coaching, those right areas where you do have bottlenecks within your process, and just understanding where this is happening is, I think, the biggest and first problem that customers take on when they come to us.
Great. Thanks, Eric. And the final question that we have is, how do you utilize no code while controlling the citizen developers?
How do we use no code when while controlling citizen developers? Well, I think there's a bigger question here, which is one of unfettered you want to empower citizen developers to solve the problems that they're facing within their operation. If not checked, that can lead to like unfettered development and chaos, right? So then the next question is, how do you appropriately govern these types of implementations? And we don't have time to get into it today, but we've got a whole governance structure within Tulip. And so you have app development, you have approval processes, you have strict controls over what can actually be published into the operation. You have an internal set of best practices, an internal app exchange that is made available with Tulip, with curated applications that come from either Tulip or this is available on our website if you go to our library. Or more typically within the context of an enterprise, you have the Center of Excellence or an IT department who will typically come in and manage those connections with backend systems, provides best practices. That's usually the starting place for our citizen developers as they get started. And there's a whole bunch more to it, but that's at a high level. You need to enable the citizen developers. You also need appropriate governance, and our platform accommodates both.
Great. Well, that's all the time we have for today. Thank you so much, everyone who stayed on for the Q&A, and thank you so much, Eric and Mark, for discussing this today.
My pleasure. Thanks for having me.
Thanks, everyone.